Hi there, folks. Today we're looking at properties of parallel lines. Previously, we looked at the angles that are formed by a transversal, but now we're going to look at those same angles, but the transversal is going to be intersecting parallel lines. And what happens is now there's a special relationship in terms of the measurements of those angle pairs that we were looking at. So the first thing is the postulate, the corresponding angles postulate, which basically says if a transversal intersects two parallel lines, so we have a transversal and the lines that being intersected are parallel lines, it's really important, then the corresponding angles are congruent. All right. And when you look at the picture, you can probably accept this pretty reasonably as a fact. Like when you look at angles that are in the same spot, like angle 2 and angle 6, yeah, they look congruent. But if you start thinking about it deeper than that, because again, we can't just go on looks alone, but think about it a little bit deeper in terms of like the slope of parallel lines and that kind of stuff that you know from algebra. You know that parallel lines have the same slope. In other words, they go off at the same angle, all right? And that's kind of how we realize that, oh, those have to be the same, because essentially what happens is that transversal, by intersecting two parallel lines, is just kind of transplanting that angle from one place to the next, okay? It's displaying the same angle because the slopes of the parallel lines are the same, and the slope is kind of the angle of that line, all right? And so we kind of accept this as a truth, and we could prove it with things like constructions, but the fact of the matter is we're not doing those in this kind of online format, all right? But the corresponding angles are congruent. So right here, in order to show that two lines are parallel, what we do is we use this little mark. So it's a little arrow through each. And just like all the rest of our symbols, you know, like the little dashes that we put to show that lines are congruent. The number of arcs shows that angles are congruent. These little dashes, these little arrows show that lines are parallel. And if I had another set of lines off to the side over here, not parallel to the first, but parallel to each other, I designate it by doing multiple sets, just like I do with everything else. So that formatting is still in place. So think about those symbols as kind of being used in the same way for each of our different kind of scenarios, okay? So for this one, if I put those little dashes through there, now it's showing me that these are parallel lines. So I would say that M is parallel to L. And now in terms of matching up the angles, angle 1 is congruent to, well, look at the corresponding angle. Look at the position of angle 1. Look at the other group and say which angle is in the same spot. That would be angle 5. If I did angle 2, once again, the one that's in the same spot in that lower group of angles would be angle 6. Angle 3, look at the angle that's in the same spot. That's angle 7. And then angle 4, the angle that's in the same spot is angle 8. Okay? So when we have parallel lines, and again, only when we have parallel lines, the corresponding angles are congruent. If you look at the previous lesson where we just examined what are corresponding angles, in that scenario, they weren't congruent. They're only congruent when I have parallel lines. Okay? If I look at something like this guy, it says alternate interior angles theorem. I want to prove that the alternate interior angles are congruent. So I'm given that I have parallel lines. It says that, given M is parallel to L. And I want to prove that angle 3 and angle 6 are congruent. And when you look at angle 3 and angle 6, that's an example of alternate interior angles. So I'm trying to prove that alternate interior angles are congruent. So here I go, statements and reasons. And again, I can use any of the postulates, definitions, and theorems that we have done so far. Okay? So let's see. Step 1, I'm going to state that M is parallel to L. And in fact, I would go so far as to mark it on my picture here because that's just easier for me to look at. When I glance up at the picture, it's always okay to label things on the picture. It's a great idea. And I know that because it was given the problem said so. Because the problem told me so. It revealed it to me. So now I have to start thinking about what I know, all right? And I'm trying to relate angle 3 and angle 6, okay? And so I start thinking about angle 3 and angle 6, and I start thinking about what other angles I know that they're congruent to. So if I looked at angle 3, I would start to ask myself, well, which angles do I know are the same as angle 3, all right? And based on the previous postulate that we just looked at, you might jump to and say angle 3 is congruent to angle 7. And the question is, how do I know that they're congruent? Well, what kind of angles are those? Those are corresponding angles. And again, that's the postulate that I have. You can just say corresponding angles of parallel lines congruent. All right. And I'm abbreviating the postulate. If you can remember that it's a postulate and say, hey, corresponding angles postulate, I'll accept that. But again, those names are arbitrary. Just describe it to me. All right. And so now I have this relationship. Now I know angle 7, all right, is the same as angle 3. But I want to get angle 3 equal to congruent to angle 6. Well, think about what I just figured out. And look at angle 7, where angle 7 is, and angle 6, and you should remember the relationship between those two things. What kind of angles are 7 and 6? Well, those are vertical angles. Remember that really lengthy proof we had? That was a lot of fun, all right? Aren't you glad we don't have to prove that anymore? We had a theorem where we realized that vertical angles are the same, okay? So I can say that angle 7 is congruent to angle 6. And I can say that because they're vertical angles, and I already know that vertical angles are congruent. And that's all I have to say. I don't have to prove that theorem again. That's part of our toolkit now. We're allowed to use that whenever we want. And now hopefully here you see the fourth step. If 3 is congruent to 7 and 7 is congruent to 6, well then guess what? Angle 3 is congruent to angle 6. And that, of course, is our transitive property. Again, if you want to say something like substitution, there's really not that big of a difference in terms of those things, okay? So now what I've proven, and here's the theorem I have, alternate interior angles. Basically, if a transversal intersects two parallel lines, so same conditions, got to be parallel lines, then the alternate interior angles are congruent, okay? So now I know that corresponding angles are congruent. I also know that alternate interior angles are congruent, okay? Next, we're going to do same side interior angles theorem, all right? And so what I'm given here is that M and L are parallel, all right? So now I know I have parallel lines, and I want to prove that angle 3 and 5 are supplementary. And so angle 3 and 5 are same side interior angles, so I'm trying to prove that same side interior angles are supplementary, okay? In other words, that they add up to 180. So I'm going to mark the parallel lines on my picture again because I like to have it done that way. All right, statements and reasons, here we go. I always start with my given, so I'm going to start by saying, well, M is parallel to L, and I know that because the problem said so, and I believe it. All right, so that's given. So now I start thinking about what else I know. I want to relate angle 3 and angle 5, okay? And there are a lot of ways, like even that previous example, there were a couple ways we could do the previous proof, okay? You could have started with vertical angles and then gone to corresponding angles and gotten to the same result. This one, there are a bunch of different ways that you can do this thing, okay? Usually I would let students kind of go on a little bit of a wild goose chase, and if we do a 12-step proof, then we do a 12-step proof. But since I don't have anybody throwing feedback at me, I guess we're going to have to do it one of the more efficient ways, which is sad, but I guess, happy from the perspective of you who has to sit here and listen to me drone on for, 30 minutes. But anyway, so the step 2, let's just think about the things that we already know. I'm trying to relate angle 3 and angle 5, right? And here's the thing. I know that angle 3 is congruent to something like angle 6, isn't it? So I could say that angle 3 is congruent to angle 6. And see, I know that from the previous theorem that I just proved moments ago. That's now part of my toolkit. And I can say that because alternate interior angles of parallel lines are congruent. Again, I'm just describing it. Say I got parallel lines, alternate interior angles are congruent, okay? And so that might not seem like a significant step, but as you look at it, hopefully you're going, wait a minute. I know that there's a relationship between angle 5 and angle 6, right? And so here's the thing, angle 5 and angle 6, you should be able to tell that those are supplementary because from the picture, that is a linear pair. And yeah, I guess from a technical perspective, we could state that they're a linear pair first all right, but again, reasonable justification, we can jump right to this. I'm fine with this and say, hey, angle 5 and angle 6 are supplementary angles. And I know that because look at them. They're a linear pair. All right, they form a line. And we can say that because and again, that's the linear pair postulate. All right. We can just say linear pair is supplementary. Okay. And now from here, I know that 5 and 6 are supplementary angles. And I know that 3 and 6 are the same. And this is one you might not remember, but we proved this the other day, where if basically I have two congruent angles that are, and one of those is supplementary to another angle, then the congruent angle also has to be supplementary. Okay, I believe our book called it the supplementary congruent supplementary angles theorem, something like that. I don't remember, to be perfectly honest with it, because every book calls it something different. But I can immediately say that angle 5, or maybe I'll say angle 3 because that's the way it's listed in the prove statement, so it looks nicer. Angle 3 and angle 5 are supplementary angles. Okay? And I can say that because, once again, angle 5 and 6 were supplements, and angles 3 and 6 are the same, so that means angles 3 and 5 must be supplements also. Okay? So if an angle is a supplement to one angle, then it is a supplement. Oh, that's terrible looking. Oh boy, the computer's starting to slow down. To a congruent angle. Okay? And again, that was part of that theorem we proved the other day. If you don't remember that theorem, this becomes a pretty long proof. Okay? I think last time I did this with students, we ended up getting to like 10 steps or something like that before we all were on the same page. All right? But there's lots of different ways you can do this one and still get the right answer and still get to that prove statement. Okay? But if we remember that special theorem we had the other day, hey, angles 5 and 6 are supplementary, and 3 and 6 are the same, so 5 and 3 have to be supplements also, okay? Because that angle is supplementary to one of those angles, it's got to be supplementary to a congruent angle, okay? And that's it. We've just proven that 3 and 5 are supplementary, so we've proven that same side interior angles are supplementary. Okay, so same side interior angles are supplementary. So if a transversal intersects two parallel lines, there it is again, it's got to be parallel lines, then the same side interior angles are supplementary. Okay, the last theorem we're going to look at here is alternate exterior angles. All right, alternate exterior angles, I'm going to try to prove that those are congruent. We can see that based on the statement here. So given that these lines are parallel, let me mark them. All right, I want to prove that 1 and 8, and 1 and 8 are an example of alternate exterior angles, okay? And so I want to prove that those are congruent, and you'll see that if you followed along with the proof for alternate interior angles are congruent, this one's not much different, all right? This is practically the same thing. So ready? Let's start with what I know. M is parallel to L, that was given to me. Next, again, I want to relate angle 1 to angle 8. So maybe I would do something like, well, angle 1 is congruent to angle 5. And that's because those are corresponding angles. Corresponding angles of parallel lines are congruent. And now from here, I know that 5 and 8 are congruent. Angle 5 is congruent to angle 8. And that's because those are vertical angles, and we know that vertical angles are congruent. And now from here, I'm basically done. If 1 is congruent to 5 and 5 is congruent to 8, then angle 1 is congruent to angle 8. And that's my transitive property again. Okay? And so here it is, alternate exterior angles, they're congruent, all right? But once again, only if I have parallel lines. If a transversal intersects two parallel lines, alternate exterior angles are congruent. If I don't have parallel lines, all bets are off here. We don't know anything about the angles, okay? We only know the special names. Okay, when they're not parallel, we can still call them corresponding. We can still call them alternate exterior and alternate interior and side interior. But there's no special relationship between the angles. Then, okay, yeah, they have a special name, but that's it. Only when we have parallel lines do all these special properties take hold, and we have congruent angles in certain places and supplementary angles in certain places. Okay. There's one other theorem that you could come up with on your own, though I've never seen a textbook list it, and that's same side exterior angles. We don't even label those, but you could show that those are supplementary as well. Okay, so something to think about. So let's apply this to some algebraic type of examples. If I look at something like this guy, it says find the value of x. And right away, I see two pairs of parallel lines. Okay, the ones that are kind of running up and down but slightly diagonal, those are parallel. And then the ones running horizontally are also parallel. Okay, and so notice the number of little arrows on each. Okay, if the number of arrows match, then those lines are parallel. Okay, and so when I look at this thing, I just kind of have to start jumping around here. Like if I were to look at this group of angles right here, now this is my transversal. Okay, see, because I'm using those horizontal lines as the parallel lines, so now I'm looking at this group. And so if I have a 105 degree angle down in that bottom group, what other angle do I immediately know in that top group? Think about corresponding angles and where I can place that thing. I immediately know that this is 105 degrees. Okay? And so now let's kind of start over and say, you know what? Let's look at this other set of parallel lines. If I looked at the other set of parallel lines here, the ones that are kind of running up and down slightly diagonal, now this guy would be my transversal. So this would be my transversal, and I'm looking at the other set of parallel lines. So now if I take a snapshot here and a snapshot here, think about where I can transfer these things, or think about the relationship between the 105 and the x. And if you realize that those are same side interior angles, then you know x and 105 are supplementary. But maybe you don't. Maybe you prefer to jump over here and say, well, I know this one's 105. Right? Because they're corresponding. And now maybe it's a little bit more obvious that that forms a line. You know that that is a straight angle, that's a linear pair. So now these two together, the 105 and the x, have to equal 180 degrees. Okay? So you subtract that 105 from each side, and you end up with 75. Okay? So x is 75, and notice I didn't put the degree symbol on because it's kind of built into the problem over here. If you were to write 75 degrees, I probably wouldn't care, all right? It's better to have the degree symbol than not, okay? If I look at something like this guy, it says find the value of y this time, all right? And so again, start looking at the relationship between these things. And maybe you would prefer to kind of look at this and say, wait, so the parallel lines are these guys up here, so this is my transversal this time, okay? This guy could also be a transversal, but I don't want to look at that one as the transversal for the moment. So when we look at this guy right here, this entire angle and this entire angle are same side interior if I kind of ignore that other line. So those two together are supplementary. They equal 180. And again, if you're uncomfortable with that, transfer it. Take a snapshot and say, hey, this angle is in the same position. Now it should be obvious that that 80, the 40, and the y all together equal the 180. So I combine some like terms. I subtract that 120 from each side, and I get a 60. Okay? And again, if you put 60 degrees, that's going to be okay. All right? If I look at something like this guy, it says find the value of x and the measure of each angle this time. Hopefully the other one didn't tell me to find the measure of each angle, because then I ignored it. Okay, it didn't. So if I look at something like this guy, again, I have to figure out what kind of relationship those have, or maybe I want to rewrite this somewhere. See, those are actually exterior angles, and they're on the same side. And that's the one I mentioned earlier. We don't technically have a theorem for that. However, take a snapshot. If you take a snapshot here and the snapshot here, let's match these things up. That 2x would go right here, wouldn't it? And so if that 2x goes right there, well, now I can see that that's a linear pair, and that those two added together equals the 180, okay? And so again, it's just a matter of kind of jumping around here and figuring out, okay, where can I relabel this angle? Which angles are congruent? Which angles are supplementary? Based on the transversal and the parallel lines. So here I've got 2x plus 5x minus 60 equals the 180. And so once again, I combine some like terms. That's going to give me a 7x. I'm going to add that 60 over to the other side. That looks like a 240. And then, of course, I'm going to divide each side by that 7, which gives me something obnoxious. Of course it does. 34.29 if I kind of round it off. But then it asks me to find each of these, so I have to plug it back in. One of those, the 2x, this angle, is going to be 68.57. And then the other angle, you could just subtract the 180. But a good way, again, to kind of check it, that gives me a 111.43. A good way to check that would be to actually plug that 34.29 in there and multiply it by the 5 and subtract to the 60, all right? Just to check it, okay? But again. And I didn't round off. If you round it off, I didn't actually plug the 34.29 in. If you do, it changes these slightly. Sorry, I should clarify that. So I did not round it off in my calculator. If you do round it off, it looks more like this. And then a 68.55 instead, okay? And again, I would accept either one of those. Usually I would tell you how far to round off if I knew it was going to come out as a decimal, okay? If I look at something like this guy, find the value of x and y, then find the measure of each angle. And so I see those parallel lines. I have two different transversals here. And so maybe you want to extend those a little bit, extend the parallel lines. All right, might make it easier to see. And maybe extend this transversal a little bit. Now, hopefully, you can kind of see what's going on here. Now, can you see that 2x and the x minus 12 as a pair of same-side interior angles? Okay, which means these guys add up to 180. And again, you can scoot one of those guys around if you want. If you'd rather label one of the corresponding angles and then do the this plus this equals 180, that would be fine as well. Here I got to add that 12 to each side, so that gives me a 192, and then divide each side by the 3, so I get a 64. The same thing occurs on the other side. Again, if I were to extend this line a little bit, extend that transversal, now hopefully it's easier to see that those are once again same side interior angles. So that means they add up to 180. Let me put a little split here. So that's the 3y plus the y plus 20 equals the 180. Okay, combine like terms. Subtract that 20 from each side and divide by the 4. Okay? But now I still didn't quite answer the question. I found x and y just like it asked me to, but it also asked me to find the measurement of each angle, so I have to plug each of these in. This guy is 128 degrees. This one down here, is a, 64 to plug in, so that's a 52 degree. Up here, this is a 120 degree. And then down here, this is a 60 degree. And see, I just plugged each of those in, but now I can also check them to make sure that these are supplements, okay? The 128 and the 52, the 120 and the 60, okay?